Hello everyone, my name is Matthew Rocklin, and I'm excited to talk to you today about who uses Dask. This is a very common question we get, and usually people mean one of two things. They mean, is Dask widely used? Can I trust it? Or they mean, do people like me use Dask? Looking for sort of social proofing that other people in their field use Dask as well. The answer is yes, people like you use Dask all the time. This talk, we're going to talk about a few use cases of Dask, both quantitatively and then on a sort of vertical by vertical basis. First, quantitatively, we're going to look at some data. Is Dask widely used? If I were trying to impress you, I would tell you that Dask has 100,000 downloads every day. This is looking at PyPy statistics, PyPI, the Python package index. This looks great. Sounds like there's 100,000 new users every day. This is a lie though. These are mostly bots. If you break down this data, you'll find that most of these are Linux, they're running Python 3.7. These don't quite look like humans. Windows and OS X, which are sort of more likely representative of human beings, are a far second and third. We know that this is the case because many users tend to use laptops with Dask. There are many people who use it on cluster level machines, but that's infrequent. More or less, we expect people to be running Dask on Windows machines and on MacBook Pros. So download counts are, generally speaking, a poor proxy for user counts. Instead, my favorite metric is weekly unique IPs. So this is looking at every time a unique person comes to the web page every week. This is a little bit optimistic because not everyone who reads the docs is a user, right? If you go to dask.org right now, you'll be counted. It's also a bit pessimistic because not every user who reads docs, not every user reads our docs on a weekly basis. I wish that was the case. But still, this looks a little bit more organic. This sort of feels about right. There's a lot more quantitative data on the Dask user survey. We ran this last year in 2019, and you can read lots of information about who uses Dask and why and how on a more quantitative level. Additionally, if you want to participate, we would love it if you went to dask.org right now, or maybe just after this talk, and took the survey. It would help. It would help us understand you as a Dask user or as someone who's interested in using Dask. Tell us about your needs, and that really helps the project. So, another survey that's valuable to look at here is the Python Developer Survey. So this is a survey put out by the Python Software Foundation and JetBrains that surveys many thousands of Python users, and they ask who uses which big data platform. So Dask is about 5%. So among people who took this survey, about 5% of Python users use Dask today. This is lower than systems like Spark and Kafka, which have been around a bit longer, but still not bad. I mean, we're more popular than systems like Hive or Flink. So Dask is still not the dominant big data platform, but we're pretty big and we're growing. Again, that's at the Python Developer Survey. I recommend taking a look. There's a lot of other fascinating information in there. So that's the quantitative side of this presentation. That was short and sweet. Mostly I'm excited to go into anecdotes because anecdotes are just more fun than data. So we're going to talk about a few different domains in which Dask is used using specific examples. We're talking about only a few domains. Dask is actually used pretty much everywhere that Python is used and there are big data problems. This is going to show you some examples that are particularly open, where people have been public about their use. We won't talk about more private industries that are also heavy users of Dask, like financial hedge funds, or government use. So this presentation is very, very biased, a bit towards science, because they're a bit more open, and a bit towards large corporations that we've worked with and are comfortable sharing their workloads. But still, there's a lot of other Dask use out there that we won't get to talk about today, unfortunately. So we're going to start with life sciences, mostly because I want to show you this image. This is an image of a cell that actually had to downscale pretty aggressively to fit into this presentation. High resolution cellular imagery is a great example of where Dask is really commonly used. This slice is actually only a two-dimensional slice out of a three-dimensional data set that's actually also moving through time. So this is really just a really small sample of what you get with high-end microscopes today. Another good example of that is this video showing, again, various views of a three-dimensional movie. The red blob here is a T cell and it is interacting with or eating another cell. So as we think about our immune system today in response, this is something we think about. What happens a lot is that these data sets are growing in size. Our ability to collect them is far outstripping our ability to analyze them. We really don't have the tools to do that today. But people like Tyler Lambert say that he can prototype on his pipelines on his laptop and then scale them easily to his institution's compute cluster. The fact that Dask mimics common APIs makes adopting it nearly effortless. Tally here is part of a consortium of many people. He's at the Harvard Medical School, but the other people at Howard Hughes Medical Institute, Chan Zuckerberg Initiative, UC Berkeley, and many other institutes that are now using Dask to deal with this kind of data. Similarly, 𝐸𝐸𝐸 from Novartis has very similar things to say. He says that it is painless to get Dask set up because all of his data are already on-premise and HPC accessible. So because Dask is culturally familiar to the HPC space, it's easy to maintain those existing workflows. And maintaining existing workflows is something that 𝐸𝐸𝐸, a notable data scientist, cares a lot about. He very much cares about that workflow because it keeps him productive. So let's switch away from finance for a second and into finance. Sorry, switch away from biomedical imagery and medicine into finance. So Capital One is a major user of Dask today. The team at the Center for Machine Learning at Capital One just goes through Capital One workflows and accelerates them with a variety of technologies, but often using Dask. I'm going to steal a few slides here from a recent talk that was given about a month ago from Kyle Nicholson and Mike McCarty, where they talk about one of those pipelines that they accelerate. So they have a fairly traditional pipeline here using tools like Pandas, Scikit-learn, XGBoost, where they're training on a subset of data that's important to the bank. I think the full data set is around 1 terabyte, but they've only ever been able to get this thing running on about 40 gigabytes of data at once. It takes around 2.5 weeks to train the whole pipeline, especially given all the hyperparameter optimization that they're doing. So the first thing that they did is they just ran this pipeline in parallel in an embarrassingly parallel way. So they spun up a bunch of Dask workers on the cloud, and they got like a 10x reduction in time. And that allows them to iterate much more quickly, right? If they wait 2.5 weeks every time for this model to run, you're not going to change it very often. You're going to change it once a year, once every few months maybe. Now they can change it every day, every week, and that improves their model accuracy over time. But this is just the beginning. They use Dask in a very simple way at first, and then they use Dask across every stage of the system, right? Dask can be used to do embarrassingly parallel workflows, or it can be used to accelerate each individual stage using libraries like Dask Data Frame, Dask.ML, or the native Dask XGBoost integration. Then they can go a step further, and they can use Dask alongside systems like Rapids. Rapids is a GPU-accelerated version of Pandas and Scikit-learn and XGBoost, which gives incredible speedups, especially when you pair it with Dask. So now they're able to get not a 10x speedup, but a 100x speedup. Now, GPUs and distributed clusters are a bit more expensive, so you think, oh, this is going to cost a bit more. And it does, but because it's so fast, there's still a 97% reduction in training cost. So while they started spending around $30 to train a sample of data set, they were able to get that down to $1 for that same sample, where now they can actually operate on their whole data set and still spend roughly the same amount of money, about twice as much. But now they're operating not on 40 gigabytes, but on 1.1 terabytes. So this is, again, an example of a workload that the team at Capital One, the Dask team at Capital One, has worked on. There are many others. I recommend checking them out. They've got a great talk at the GTC conference. So that example was a very traditional machine learning example, right? Reading in some data, doing some feature engineering, running a machine learning model, scoring the results. A lot of use cases in finance aren't that simple. A really common use case that we see happening at Barclays and actually like 3 or 4 other name brand banks is financial system modeling or credit risk modeling. Here, it's not a question of big data, it's a question of complex systems. So the image here on the left is represents a complicated system where every little point is one Python model. It might be using systems like Pandas or Scikit-learn or PyTorch on small sets of data. But there's many models that are all related to each other. And those relations are really hard to represent, really hard to model that way. But Dask, because it's a sort of arbitrary dynamic task scheduler, it can manage more complicated systems like this, right? So if you look at something like Spark or MapReduce, they require a lot of regularity in the computation. And this computation is not regular. It's very messy, and Dask really thrives in that messiness. We see this a lot in financial institutions like banks, like Barclays, who is public with this use case. Many others, again, if you have a credit card in your wallet, it's probably running on Dask today. And also lots of hedge funds. Most hedge funds have a system like this internally. They saw Dask and said, that's great. That's exactly what we wanted. It's better than the system that we had. What's also interesting in the banking use case is that many times they're actually not running this in parallel. They're not running this on a cluster. What they actually care much more about is the fact that Dask is flexible enough to hold on to the workload, and then that they can instrument Dask with arbitrary Python code before and after every task runs. This ends up being critical to handle regulatory concerns. So a lot of banks are under a lot of regulation to make sure that they're doing things correctly. And they want to track every single computation that they do. And running in a system like Dask gives you the ability to define your own policies. And Dask's flexibility is really helpful in that case. So we'll switch back from finance, back into the sciences. This is one of my favorite images. So when I was making this talk, I reached out to a bunch of people, said, hey, send me beautiful images that you work on. This is an image of the ocean currents from a simulation, and then we analyze that simulation with Dask and a library called Xarray. So in a lot of the geophysical sciences, like climate science or meteorology, which we'll see examples from, but also the energy industry, hydrology, satellite imagery, we often produce very large simulations of data. So on the left here, we have a simulation of the Earth's oceans that runs on a giant supercomputer. And this produces about a petabyte data set. We've actually gotten really good at producing these data sets, much more than we are at consuming them. So oceanographers today actually really can't look at the data sets that they're producing, except by now using tools like Dask. To be clear, Dask is not a good petabyte scale tool set yet, but at sort of the 10 terabyte, 100 terabyte scale, we can look at these things, and that's really exciting. Shell from the Feller Institute, a NASA scientist, says that she uses Dask to decrease the time she spends computing and programming and increasing the time that she can spend on analyzing results. And that's really important. Dask is allowing scientists to become scientists again, rather than thinking about data engineering and IT concerns. Also, a really fun use case, at Los Alamos National Labs, one of the US Department of Energy national labs, they do a lot of seismology research. In particular, Jonathan McCarthy looks at massive time series. So they're looking for, if there's a nuclear explosion somewhere underground, or if a mine collapses, or there's an earthquake, they have a bunch of sensors around the Earth collecting very long and very numerous time series. And then they want to analyze all those time series together to get interesting signal out of them. And Dask allows researchers like Jonathan to answer some expensive questions that he wouldn't have been able to answer otherwise, because previously he would have had to switch out from Python and dedicate some time writing C++ MPI code, which is a big upset to his workflow. Now Jonathan says we're able to rapidly gain insights into these questions with minimal changes to his research tooling. And that's a big change. We're allowing these people to handle large data sets in the way that they're comfortable, using pure Python technologies, using existing APIs like NumPy, Pandas, scikit-learn, Xarray, etc. Another good use case here I'd like to highlight for a few reasons is the UK Met Office. So the UK Met Office is like the National Weather Service for the United Kingdom. And they run big simulations like what we saw with the oceans. They also have lots of observations from satellites, from weather stations around the world. The Met Office is actually sort of part of the UK military. Its weather prediction is critical. It's good if you're going to the beach and you want to know whether or not you should bring sunscreen, but it's also good if you want to be alerted if there's a hurricane that's going to destroy your town in the next couple of days, or if you want to keep shipping on track. Weather prediction has actually saved lives and billions of dollars every year. So it's really critical. The UK Met Office is interesting because they have around 500 analysts that analyze this data every day. Their adoption of Dask paints an interesting story. This is actually really common. So the Met Office had some in-house software called Iris, which their analysts have been using for years, well before Dask ever showed up. And they've got lots of legacy systems running with Dask. They have lots of in-house expertise with Iris, but they wanted to now get the flexibility and the scalability that Dask allows. So working with the open source community, employees at the Met Office replaced the Iris internals with Dask and with the Dask NumPy connection. And that gave them the ability to scale out, but without expensive rewriting or retraining. We didn't have to tell everyone how to use Dask. They got to keep using Iris because Dask is now running underneath and inside of Iris. Now that they had done this, they were also able to deploy Dask on their on-prem HPC hardware, the same hardware that's being used to simulate their massive weather predictions. Also, the Met Office is transitioning heavily into the cloud. They're actually one of the largest AWS users in the cloud in the UK. And now they're sort of thinking about going to Azure in order to remain cloud agnostic. They want to be able to switch back and forth. And so Dask was useful early on to help them accelerate all their workloads on workstations, but has also been critical in helping them transition from their HPC environment to a more hybrid architecture to a multi-cloud architecture. And Dask is really helpful in that process because it can work anywhere. Additionally, the Met Office has been really fascinating to see because they've influenced many other institutions in their community. So that now actually most national weather services use Dask to analyze large data sets. In the UK, that's institutions like the Met Office and the Hydrographic Office. In the US, it's institutions like the National Center for Atmospheric Research, NASA, the USGS, and there are other systems like this around the world. And so there's a huge community of people that have really held on to this technology and have built a community around it. We're going to pangeo.io if you want to learn more, and a bunch of additional software. Now, most people in this community who use Dask don't even know that they're using Dask. They're using Dask underneath other systems, and that's really what we like to see. So the Met Office is really an example of the full arc of Dask adoption that we see in more vertically oriented communities like the geosciences. Again, this isn't just meteorology. There's systems like USGS, which analyzes hundreds of terabytes of data with Dask to look at things like coastal erosion, and a variety of other systems. I wanted to add in just one example for light sources, but Brookhaven National Lab is super interesting. So Brookhaven is another Department of Energy national lab, and they have a synchrotron on site, which is a large facility that sends high energy particles and smashes them into interesting materials. And this system produces two really interesting data challenges. One is at a particular site, there's a high volume of high quality imagery coming off of one of these detectors. It could be anywhere in the sort of gigabyte per second to 10 gigabytes per second bandwidth. That's like taking a high resolution camera and taking a picture about once every millisecond. And that's intense. Now that data volume isn't huge for something like Google, but to recall, this is coming off of one machine. In order to analyze that data effectively, we have to use hardware at a core native level. So we can't be using systems like JVM systems. We have to be interacting with devices in a raw way. We have to be using GPUs very naturally. And we have to be using advanced networking like InfiniBand. And so Dask can do all of those things. Dask is one of the very few distributed computing systems that is general purpose, that can operate at this scale, that also operates with native hardware. Additionally, Brookhaven also has many, many terabytes of data they've collected over time, and they also use Dask to do that kind of analysis. So Dask can flex between on-site rapid streaming systems and offline HPC distributed computing, all on HPC hardware. Also, what's really appreciated by communities like these ones is that Dask operates with existing file formats like HDF5 and NetCDF. We're not trying to reinvent systems. So, finally, let's look at retail logistics. This is a little less sexy, except for the scale of the data. So Walmart is using Dask to develop forecasts for all of their items in all of their stores. This is taken from a great video I recommend looking at. from the director of data science labs at Walmart. There's a link over there. So Walmart has an incredible number of items in their catalog and an incredible number of stores, and they want to make sure that every item is in stock at every store to the extent that it should be. Right? So if a holiday is coming up, we should be aware of that. If it's going to rain next week, we should stock umbrellas. And this is just a huge computational problem that using libraries like Rapids and XGBoost, Walmart has been able to accelerate 100-fold in some cases. Now, if you're not Walmart, but you still want that kind of logistics, you might use a product from a company like Blue Yonder, previously called JDA. Blue Yonder uses Dask all over the place, and it powers their ETL pipelines. They process terabytes of data daily, and they really like that Dask can scale elastically. That keeps things efficient for them. It keeps things cheap, while also being very reliable. So Blue Yonder runs hundreds of Dask clusters in production every day, and Sebastian Neubauer at Blue Yonder says that it's important that data scientists are able to deploy code directly into production. This keeps feedback cycles short and waste low. So the fact that they can write pandas-like code with Dask while they're experimenting, and then push that directly into production to be actually in critical workloads is really valuable to them, and that saves them a lot of money. Finally, retail logistics at a small scale, data scientists like Alex at Grubhub use Dask alongside TensorFlow. So Alex likes Dask because it helps him iterate faster because he has only one stack. He's going to use Python because he's using TensorFlow, and that's how you use TensorFlow today. Use it with Python. But switching between Spark and the JVM and Python and TensorFlow is really challenging. If you swap out Spark for Dask, that's much more of a consolidated stack. And this makes it much more pleasant to use. You're not sort of using one system inside of another. So that's all the existing use cases we're going to talk about today. I want to make a final few notes on software libraries. So many people use Dask today without realizing it. So Dask is very much designed to be infrastructure for other libraries. We've made a lot of choices in Dask to make sure that it is simple and easy to depend on. It's pure Python. You can run it with a very simple code base, or you can scale it out. Dask scales both in and out. And that means that Dask has been integrated into lots of other libraries, which are much more effective at doing a particular thing. So we saw, for example, Iris with the UK Met Office, and that's serving a lot of people that don't really know what Dask is, but they have a particular workflow that they like using. Similarly, libraries like SatPy for satellite imagery uses Dask under the hood to solve a lot of remote sensing capabilities. This is great because the Dask maintainers don't have to maintain all this capability, and these other communities in the PyData world can onboard other communities in a more culturally sensitive way. Similarly, for time series analysis, there's libraries like Facebook's Prophet now can run on Dask, or Blue Yonder's TS-Fresh library. Both of these handle time series data in interesting ways. And so you can use them alongside libraries like Pandas or Rapids to do interesting time series analysis now at scale. In just traditional ETL machine learning workflows, there are libraries like scikit-learn, of course, which has good Dask integration, but also a variety of other libraries like feature tools, now part of Alteryx, Rapids for GPU-accelerated data science, XGBoost, Teapot. These libraries all have some level of Dask integration, and Dask is there to make sure that they can be used together at scale. Additionally, each of these libraries has their own set of users. So we saw earlier from stories like Capital One and Walmart that Rapids is heavily used inside of large industries. All of those companies think they're using Rapids, but they're also using Dask under the hood. And that's great. Dask is now infrastructure. Similarly, there's libraries like Airflow and Prefect for workflow management that allow you to run jobs on a schedule with certain retry logic and business logic. And they're really critical to run everything that we've talked about, but now in a regular production way. And so we can use Dask at a very low level to control our GPUs running a particular machine learning algorithm with XGBoost, and at a very high level when we're running all of those across a bunch of different machines, every hour on the hour. So Dask is able to be used all across the stack, from data science, data engineering to production. And there are many, many more. If you go to the Python package index and search for Dask, you'll find that as of today, there are 239 projects. Probably by the time you see this presentation, there'll be more. There's a new project with Dask every few days. Some of these are things that the Dask community maintains, but most of them aren't. Most of them are done by individuals or small companies that are increasing the ecosystem. So I'm going to show two specific examples that I really appreciate. One is 𝐬𝐨𝐬𝐞. I like this one because the Dask maintainers have gotten the request to implement SQL on Dask over and over again, and it's really hard to do. But a company like 𝐬𝐨𝐬𝐞 made their SQL engine. They didn't know about Dask at first. And what they found is that they needed to have staging beforehand. So they wanted to have people to be able to, parse more complex, messy data and then feed it into 𝐬𝐨𝐬𝐞, use 𝐬𝐨𝐬𝐞, and then on the back end, pass off to more machine learning libraries. And what they found is that by integrating with Dask, they were able to put 𝐬𝐨𝐬𝐞 in a context that let it be used in a variety of workflows. And so you can load data. You can use Dask QDF to read CSV data. You can then pop it into 𝐬𝐨𝐬𝐞, runs very efficient SQL queries on GPUs, and then pop it out and run a scikit-learn model on it, for example. So now Dask is the preferred way of deploying 𝐬𝐨𝐬𝐞, which is really exciting. Another great example here that I love is Napari. So we started with this image of this cell, and we're going to end with this image of this cell. So Napari is a biomedical image viewer. So we talked about all these really massive, four-dimensional life sciences image data sets, and how it's really hard to analyze them. It's especially hard if you don't know Python. So Napari is an image viewer that was designed to replace tools like 𝐼𝐻, which is sort of the standard in this space currently. It is a point-and-click application. So we're not serving Python users who know Jupyter Notebooks. We're serving actual lab bench scientists who don't necessarily know Python or NumPy or PyTorch. But tools like Napari allow those domain scientists to use these tools in a more effective way. So this is really exciting because this shows how not just Dask, but the entire PyData stack can be and is being deployed not just to programmers, but to everybody. Napari, I think, is one of many projects like this that we'll see in the future. So that's it. Thank you so much for your time. A few final thoughts. We asked the question, who uses Dask? The answer is quantitatively tens of thousands of individuals. They range from scientific research labs to industry fields like oil and gas or retail or finance. They range from small startups like 𝐬𝐨𝐬𝐞 to the largest corporations on the earth. We're also seeing increasing amounts of indirect use of Dask. Most people using Dask today are using it under something else. So that's it. As a final call, if you have time, take the Dask 2020 survey at dask.org/survey. We would love to hear more. My name is Matthew Rocklin. I'm one of the lead maintainers of Dask, and I work for 𝐶oiled. 𝐶oiled is a for-profit company that a bunch of the Dask maintainers left to go start. So if you want some help with Dask, come and give us a shout. Thanks all for your time. Cheers.